All right. So, oh, he doesn't want to come? Tell him we'll fully on you. Okay. 6.3, traveling salesman problems. So now, not only do I have pictures with dots and lines, now I'm adding numbers. So these are called weighted graphs. Any graph whose edges have numbers assigned to them. So we're now assigning numbers. Okay, so a weight is the number along the edge or along each edge. These numbers can represent several different things. Okay, so your weights can represent the distance from each point. So it could be in miles, it could be in yards, it could be in blocks. Okay, so it can represent distance. You could make it represent time in hours and minutes, in just minutes. I've seen it where it represents cost. Okay, it could be the amount of money to put gas in your car to get from point A to point B. Okay. But we've now assigned a value to each edge. Okay, so they call these the traveling salesman problems. From home, the traveling salesman must visit different destinations to sell goods and return home. This is essentially finding a Hamilton circuit. So our goal from here on out is to find the cheapest, most efficient, optimal route. So we're looking for small. Okay. So the smallest distance, the smallest time, the smallest cost. Okay. So, fan favorite, because most of you know them, The Simpsons. Okay. So, Homer Simpson. Homer Simpson has some favorite places, like Moe's Bar. Okay. He likes to go to the Quickie Mart. And he likes to go to the retirement home to visit Grandpa. Well, we're going to pretend that he actually likes him. You know, we go visit the old man every once in a while. Okay. So, assuming that he wants to begin and end every day back in his crib, because that's what they told me to call it last period. It's crib. It's not his home, it's his crib. It's all right. Okay, so saying that he wants to go back home and start at home every day, they want us to find the easiest way or the cheapest way to do this. So, this first one says, what if Homer wants to go see Grandpa first? What ways can he leave home, go to all of his destinations with visiting Grandpa first? So, A to B. That's from home to Grandpa. We have to go to every destination. So C to D and back to A. So he can go from home to the retirement home, to the Quickie Mart, to Moe's, and back home. How else can he travel if he wants to start at home and go to Grandpa? Okay, so I can switch the Quickie Mart and Moe's. So we can go from the home to the retirement, to Moe's, to the Quickie Mart, and back home. Is there any other way for Homer to leave home, go visit Grandpa, visit every place else, and get back home? No, that's it. Okay, so now we need to figure out which one do we want to use. So the way we do that is we figure out how long it takes to do this. So A to B
12.
is 12. B to C is 20. C to D
17.
is 17. And D back home is 8.
I got 57. I don't know if that's correct.
That sounds right. We're going to say this is in blocks. I don't know.
Is this what we do?
It's a lot of
Dang,
blocks.
I'm about to say this is a lot of
Man.
I mean, if we counted it as miles, that's a lot of miles too.
Yeah, you're right. It's a lot of whatever.
It's a lot of whatever. Maybe if I walked 57 blocks, I'd lose some of this.
It don't work.
It doesn't? Dang. You just kind of depressed me there. Okay, so let's also see the distance if we did it this way. So A to B,
12.
that's still 12. B to D now
15.
is 15. D to C
17.
is 17. And C back home
Wait.
is
Oh,
20.
that's gonna be way more.
It's 64.
64 blocks.
Not way more, but it's still more.
So looking at these two ways, my optimal route
ABCD.
would be your first one.
That's easy piece. How hard? How much harder?
I don't want to say it gets harder. I give you different ways to do it.
But it's all adding every time.
Yeah, that doesn't get any harder. You have to add everything. Okay.
All
right. So let's look at this one then. They want to know, what if Homer wants to go to the Quickie Mart last? So he wants to end this as Quickie Mart and then home. So we always want to finish with C, home.
A, B, D, C.
A, B, D, C, A.
Or A, B, C. I mean, A, B, B, C.
A, B, B, C, A. Okay, well, if you look at that first one you just listed, that was this one. We already did that. So instead of adding that all up again, we already know that this is 64. Okay, it's the same thing. Okay, the last one though, A to D is 8.
B to D is what, 50?
D to B is 15.
B to C.
B to C is 20. And C to A is 20.
That's the closest.
63.
Yeah.
Okay. So 63 blocks. So even though it's a block shorter, that one's still optimal. Scenic route.
About 1 block?
About 1 block.
Hey, you don't know it could be a stoplight right there.
What?
Traffic.
Right. I mean, he's got a point. You could be at one of those red lights where you just sit there.
Y'all run like a red light. There's a red light by my house that lasts for 15 minutes.
Amen. I hate that one.
Which one? Good thing I
What's Fifth Avenue?
I don't know what that's.
Main Street's become a bear anymore. There was an accident on Main Street the other day when I
You'll
was
be lucky if you get all green.
I do that all the time.
Okay, so how do we do this? Okay, so we are going to talk about 4 algorithms between today and tomorrow on how to do this. Okay, so an algorithm is just a way to solve a problem. Okay, don't get freaked out because it's a big word. I say algorithm, people are like, oh my God, what does that mean? No, it's just a way to solve a problem. Okay, don't freak out. Okay, so the 2 we're going to learn today. The first one is called brute force. When you think of the words brute force, what do you think? You're forcing something. Okay. They also call this the exhaustive search. This is the hardest one that you're going to do.
Jesus Christ.
You already messed up? Okay, so brute force is where you list out every Hamilton circuit that is possible. Okay. So take a look at this one. This is a graph. This is a complete graph with 4 vertices. So how many Hamilton circuits should we have? Oh, this is taking you back to yesterday.
4 verses.
4 vertices, which means each has a degree of
2.
3,
Well,
and 3 factorial is 6.
I said that. Go ahead.
So 4 vertices, each has a degree of 3. So 3 factorial is 3 times 2 times 1. So you should have to list 6 Hamilton circuits for this one. Okay, so your first Hamilton circuit, A to B, B to C, C to D, back to A. Don't forget, it is a distinct circuit if I take that and reverse it. So its mirror image is A to D, D to C, C to B, and back to A. Okay, give me another one.
A.
A, B, oh, A, C, B, D, A.
A, C, B, D, A. Which again, reverse. A, D, B, C, A.
Oh. I've been doing this wrong.
A, C.
A, C. You're right. Keep going.
B, D, A.
A, C, D, B, A. Or A, B, D, C, A. You just listed out all 6.
Cool. So if on the way, we gotta add.
Okay. So now I need to find the weight. Beautiful thing though. If I'm going from A, B, C, D, A, or in reverse, A, D, C, B, A,
It's the same.
it's going to be the same weight.
Oh my god.
Because all you're doing is doing it in reverse.
Oh my god.
So you only have to add up 3 different ones. So here, A to B is 13. B to C is 9. C to D is 14. D to A is 15.
68.
68.
No, I'm kidding. That's not the answer.
Come on, they gotta write in my paper and stuff.
Right. He gets us all kinds of messed up.
51.
51. Thank you. Right. A to C this time. So we're looking at 12. C to B is 9. B to D is 16. And D to A is 15.
It's 52. Actually, I'm not even lying.
Okay. My last one. A to C, 12. C to D this time, so 14. D to B, so 16. And B to A, 13.
55.
55. So, using brute force, my answer would either be A, B, C, D, A or A, D, C, B, A with a weight of 51.
Okay.
Does it matter which way you give me, the mirror image or the regular?
No.
No. Okay. I'm not going to. Okay. The most that's going to change is I may say, write your circuit beginning at B. Okay, so the most that might change is once you figure this out, I may say rewrite the circuit to start at B. So all you would have to do is go B to C, C to D, D to A, and A back to B. Okay, so that's the most that's going to change is I'm going to ask you to shift to start somewhere else. So all you do is go to that letter and keep going in that same order starting at that letter.
So it'd be B, C, D, D, A.
So this would be B, C, D, A, B.
Alright.
Okay,
What was that?
so I know you can read this.
Jawan, you're weird.
So this is great because one, you always get your smallest circuit. What do you think is going to be the biggest problem?
I feel like this is a trick question.
Oh, you don't forget about one.
No, because you always know how many. You always know how many.
What's wrong with you, Jawan?
What would be the biggest problem?
Yeah, what's going to be my biggest problem?
The mirror image or something?
What if I tell you we're at K sub 7? How many Hamilton circuits are there?
K6.
No.
6 to your degree.
Oh, not
Times
that.
that.
Factorial.
Factorial.
What's 6
A
factorial?
big old number. A number. I don't know.
I don't know. Don't want
6 times 5 times 4 times 3 2
times
1.
7.
7 point. It's a pretty large number.
If I have 7 dots in my graph, to use brute force, you'd have to list out 720 Hamilton circuits.
What?
I thought it was that.
Who doing
So
that?
that's the problem with brute force.
Jawan's the only one
Okay.
doing that.
I would never give you a graph that big. That is insane. I would never do that to have an answer key, so I sure as heck am not going to expect you to do that.
I'm glad you're not that.
Okay, I'm not that extra. Okay, that is a lot of work. Okay, so while brute force is awesome, you always get the smaller one. It's not very good when you end up with bigger graphs. Okay, so they came up with this one instead.
Nearest neighbor. I like
Okay, this one is called your nearest neighbor. So
What?
your nearest neighbor says, wherever they tell you to start, you look for the smallest path from that point to another point. Okay, so if we go back to this graph, because I don't have it on that one, they want me to start at A. So I can either go A to B, B to C, or A to B, A to C, or A to D. Okay. I wasn't drawing lines, I was just pointing.
Oh.
Did I draw one?
Doesn't matter. Leave her alone.
It's
Okay.
perfect on the line.
Can you leave her alone, please, Dawan? Continue to teach,
He's a boy,
which is the
let him go.
important part.
Okay. So
Video.
A to B has a distance of 13. A to C has a distance of 12. A to D has a distance of 15. Who is my nearest neighbor?
C.
C. You want to go with your smallest number. So I want to go from A to C. Okay. I still need to visit every neighbor before I go back home.
Go to
So
B next.
now
B, 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 B.
I've gone from A to C. So I still need to visit
B.
neighbor D and neighbor B.
Go to B.
Okay. Rodrigo says we go from C to B.
Then go to D.
Then we go to D
Back to A.
and back to A. So A to C to B to D and back to A.
Yeah.
Okay.
I was starting to see again. You said short to get to.
Yes, it's the shortest to get to. So from A, I've got 3 options: 13, 12, or 15. You want to take your shortest path, so your smallest number.
Oh.
And then once you're at C, I either need to go to B or D. So I have 9 or 14. So my smallest number is 9. Then I have to go to D and I have to go back home. Okay, so it forces you to do the last ones. Okay. So we said A to C was what?
Huh?
What was the number for A to C?
Like
Oh,
12.
12.
Sorry.
C to B was
9,
9. B to D
16.
was,
16, 15.
what does that give me?
A number. 51.
You want to check?
56.
52?
54. 53. 53.
52.
52.
I'm sorry.
Okay, so this is easy because all you're looking for is the smallest number. What's the problem with this one? It's not what?
Accurate.
It's not accurate.
I was-
What was my small, whoa,
What are
you
you
doing?
doing?
What is-
Going?
it's going the wrong way.
They're going the wrong way.
What was my smallest one?
Oh, 51.
51. Did this give me 51?
No, ma'am.
So this is super easy, but the problem with this one is it's not optimal. It will not give you the smallest circuit.
The fastest route.
Sometimes it will, most times it won't. Okay.
What's the right one we have to use?
You gonna tell us to use it? Right on the test?
So on the test, I'm gonna tell you, here's your map, use nearest neighbor.
Why are you showing us this if it's not relevant?
Because you still have to know all of it. Your final exam could say, what's the nearest neighbor path starting at this? And you have to be able to answer that.
Yeah, the wand.
So while it's not the best one, they may still ask you it.
The wand.
Just because not gonna be a test that you.
Don't listen to the wand.
I mean, I'm gonna have all the methods on your test. So you are gonna have a brute force one, but again, I'm not gonna make it one where you have to listen to 120 different circuits.
When is the test?
It's gonna be one like you have to listen to 6. Friday.
Friday. This Friday?
Yes. We're gonna finish tomorrow, we're gonna review Thursday and test
I
Friday.
like that.
And then
Our projects are due Friday as well.
Projects are due Friday as well, at chapter 5.
If I just make a real deal, it's fun.
And take pictures of it, yes.
I still gotta upload it.
Yes, because it has to be added to your website. So it has to be uploaded and put on Canvas. Okay,
I'll let know.
Okay.
You know what?
okay. You are going to have to either take a graph and create a table, or take a table and create a graph. So we're gonna do both. Okay, so in the table, these are your starting, and this is your ending. Okay, so what would I do to fill in this first block if they want me to start at A and end at A?
But it's 8 plus 8.
Do we have an edge that goes from A to A?
No. There's no loop.
There's no loop. So A to A is non-existent.
It already don't make sense.
What do you say? Okay. All right. So there is no loop at A to A.
Put 12 in that box.
So you would put 12 in that box.
I get it. I like it. I like
A
it.
to C.
20.
It's 20. I like
20.
it. I like it.
A to D. 8.
That's 8.
A to
I like
D.
it. I like
B
Eight.
to A.
B to
Okay.
A, that's
Well,
Go to this one. B to A.
12.
12.
I like it. I like it.
B to
Not
B,
possible
no.
because there's
B
no
to B. Not
Oh.
loop.
possible.
No loop. I got it. I got it. I like
B
it.
to C. is
B to
20.
C is 20.
B to D is 15.
B to D is 15.
I like it. I like
Okay,
it.
pause for a minute.
No.
Hold on.
Pause.
No, you're lying.
Pause.
Why?
Are we all okay?
Yeah, we straight. This is something I did.
I'm just- They're
I
rolling
get it.
through this.
I get it. Come on, keep going. Before I get confused.
Oliver.
So A to B
C to D, 17.
is 12. So from A to
What don't
B
you get?
A,
is 12.
B.
I like this.
Go.
And you can't go A to A because.
There's no loop.
Okay.
A to A would be something that looked like this.
So I didn't ask you, I asked the teacher.
Don't draw a loop because then you're getting confused every
I'm
class.
going to erase it.
I don't care.
Chill. So A to A would be an edge that leaves A and goes straight back to A, which we don't have in this.
How many D's gonna be on the test?
One.
One?
Think about 8.
Okay.
What about 10 on?
If we go to the C, C to A,
That's possible. That's possible.
and C to A is
20.
20.
20.
I like that. I like
C
that.
to B,
That's 20. I like that. I like that.
C to C,
Not possible. Not possible. No, I like that. I like that.
C to D,
That's 17. I like that. I like that.
8.
D to A,
That's 8. I like that. I like that.
D to
That's
B,
15. I like that. I like that.
Oh my goodness.
D to C.
17, I like it. No loop, I like it.
Okay, so the question is, do I prefer Rodrigo awake and participating or Rodrigo asleep?
Nah, the question is who's better, Rodrigo or Tyreek? Which one's better?
That's the real question.
That's the real
I'm
question.
gonna have to add Rodrigo's name up there. I don't know though, most of the time he's asleep, so he doesn't bother me.
Oh my god.
Alright, so what do you notice about this table?
Diagonal, cross, X.
Cross.
Okay, so I've got a diagonal
With X's.
from top left
I got bingo.
to bottom right. That's a 5x5 card, thank you.
My bad.
Connect 4.
Yeah.
She says 5x5 card. Thank you.
Oh no, because they said, oh, tic-tac-toe. I said, no, this is not a 3x3.
What the? Who said this?
Last period, they said, oh, tic-tac-toe.
I'm gonna need some.
I said, not a 3x3.
Not
He just said bingo. I said, nope, not a 5x5. But we can do connect 4.
Yeah.
Connect 4.
Yeah.
Okay, so we have a diagonal from top left to bottom right with no weights. Okay, because we have no loops, you will always have that diagonal from top left to bottom right
It looks like you put bottom.
that will have no.
See it?
Looks like I put bottom one.
8.
Oh my goodness. Because my R went curly.
Just saying.
Curly whirly.
What?
Oh, now you're gonna make me erase this whole friggin' thing with the boards off.
Boy,
Rodrigo, be quiet.
there you
Is that better?
go. Yes, ma'am.
Thank you.
Okay.
The B and the O are stuck together.
Shut up.
So, extend the page.
What else do you notice?
The numbers are the same.
Yeah.
The numbers are the same. Take a look at the numbers here versus the numbers
It's samical.
here.
They equal the same.
It's a reflection.
It's a reflection.
It's a reflection over that diagonal line.
It's a reflection of the x-axis.
No, it would be a reflection over the line y equals negative
And they're in
x.
the same spot too.
Yes, I think.
Yeah,
Okay.
see, leave that in math.
Why? Why is this a reflection across that line? What is this number? A to B.
And that's
What's this number?
B.
Yeah.
B to A.
For-
So this is the reverse
exactly
of this bottom corner.
Oh.
I was saying Hey, took that.
Oh,
What is he going to do?
Homie is gone.
He just walked out.
The whole time we went.
I just got it.
Oh my
What
God.
you say? You're
All
old.
right. So, what if I have a table and I want you to draw me a picture?
Ooh. I ain't gonna say bingo.
Okay. So, how did I start this off? Why did I put 5 dots here?
Because there's 5.
There's 5.
There's 5 letters.
So you have to.
Okay. So, the first thing you want to do is draw some dots
B to A.
and add your letters. Okay. Remember,
There's no loop. I like it.
remember, what happens down here happens up here. So I don't have to do both. I only have to do one. Okay. So I need to connect A to every letter. So when I go from A to B, what is that weight according to my chart? 3. So I put a 3 there. A to C.
4.
4.
I like it.
A to D is 5. And A to E is 6. Okay, so I did everything leading A.
Yep.
B, I already connected it to A,
So that's
but I
three.
need to go to C.
That'd be 5.
B to C is 5.
That's what I just
B to
said.
D
7,
Oh,
9,
and B to E
9.
is 9.
Oh, crap.
hold on, pause.
Oh,
Dang. It was
Yeah,
a complicated
good.
part.
What you pausing for?
fine,
Oh, yeah,
Roger.
I'm on a second.
You good?
Oh, yeah.
Okay. It's fine to pause and give yourself a minute to wrap your head around it.
No, it's
C
not.
to D.
We okay?
Yeah.
Yeah.
I don't know. Let's ask Princess.
C to E. Right, so she be, it be taking her a little bit.
Look, y'all, I'm not gonna put y'all in the room.
Listen, Princess, let me just tell you this.
Yes,
They're asking themselves the same question in their head. They just don't want to voice it out loud.
Right, and I don't care about y'all.
Amen. It's your education. All right.
got it.
So we did all of my A's, all of my B's. C is already connected to A and to B. C to D though.
7. No, that's 6. That's 6.
C to D is 6.
That's what I just said.
And C to E
It's 8.
8.
is 8.
Oh, look at this star.
Okay.
It's the.
D is connected to everything except for E, which is
1.
1.
Done.
That's it.
This is a little
Wait,
complicated.
period.
Yeah.
It's a pentagon with a little, ooh, miss, why you do that like that?
That's a star.
Oh, you're a devil. Oh,
Right,
you're a
I'm a
devil.
devil.
worshiper.
You're the
Listen,
devil
we
worshiper.
cannot get away with not doing these complete graphs. I'm sorry.
Oh my gosh.
So mad.
See, all that junk connected with key.
That's a star. It was just made a
That
star.
belongs to the devil.
Okay.
It just made a star.
You just be the star.
So I'm either going to give you a table or a graph and ask you to do nearest neighbor.
That's easy.
So I'm going to show you how to do it from the table because we've already done it from a graph. Okay, so when you do it from a table, my suggestion to you is to write down all the vertices you have available. A, B, C, D, E. Because, again, Hamilton says I have to touch every vertex. So, as you use them, I want you to cross them off to make sure that you've done each of them. So, they want me to start at D. So, I crossed D off. I've used it. Okay, so you want to then look at the column D. What is my smallest number
E,
in my column?
E, 1.
E with 1.
I like it.
So now I've used E,
Now go to your E column.
okay? So now we go to the E column. I either need to pick A, B, or C. So here, here, or here.
A was 6.
And it's gonna be A
Yes,
with
maybe.
6.
I like it.
It's gonna be next one.
Okay.
Column, it's gonna be.
So I now need to go to my A column and I need to go either B or C.
B on 3.
And it's B with 3.
And they have to go-
I've gone everywhere but C.
That's
So B has to go to C, which is 5. And what everybody seems to forget then is we
Yeah,
have to go back to home.
Because it's a third.
It's a circuit. So C to D is 6.
C to D.
Oh, hold on. What did you do for that? D thing?
What?
Wait, what?
Oh, E.
E.
Where's 6 come from?
It's D.
C to D?
What? C to D, you have to put the D.
C.
C was, oh, yep, my fault.
C to D. Okay. So my total here is 21.
Is that the lowest? We don't know.
We don't know.
Y'all remember?
You can list all 24 and find out.
No, that's fine. No.
No, so basically you gotta get all the letters and write them down.
You have to touch all the letters and use the nearest neighbor.
We don't know that.
Which
We
is, okay.
So your nearest neighbor is choosing the smallest number or the shortest path from that point to another point.
Like if it was A, you would pick.
So if you started in column B, you would go from B to A, because my smallest number in that column is a 3.
So this is homework?
No, we about to do this, chill. Okay, so this is our last page. Okay, so I gave you the table and I gave you the graph.
Wow.
That's
So- We are going to use the table and then we're going to use the graph. They want us to start at vertex A. Okay, so let me go back to this. So again, my first suggestion to you is to write out all your letters so you can cross them off as you use them.
I feel like using the table is a lot easier.
I think so too.
Because if you use the graph, all those numbers get in the way.
So the bigger the graph, the more crazy lines you have, the more numbers where you have to sit there and go, which number's going with what line, huh? Okay.
That big.
Could be,
Oh, Lord. Goodness.
could be. Okay, so they want us to start at A. It's really not, but they're whiners, so we just roll with it. Okay, so we're starting at A. What is my smallest number in my A column? Okay, it's 15. Okay, so we're A and F is done.
So now we're at L.
So now we go to column F.
13 or G.
13
I think I did that right.
to G.
Then you go to column
So now we're done with G. Watch what happens when I go to G though.
22.
My smallest number is 13,
It's L.
but that's F. Already been there.
Go across it out.
It's A.
Okay?
You can't go back to A, so you have to cross
We
that out.
can't go back to A until the end because we've already been there.
Yeah.
So we can't use 22 either.
So go to C with 28.
So C with 28.
Like that. Then put the B. and then
This is why I said make sure that you're crossing off your stuff as you go so you know where you've been. Okay? So C is 28, so now I'm at C.
Go to B with 30.
Okay? My smallest there is 30, so we're going to B, and that's 30. Okay, now notice all I have left are D and E. So when I go to column B, all I want to look at are those two. So B to D is 60, B to E is 80.
Go to D.
So we want to go to D, which is 60. My only other place left to visit is E.
and then
So
go
I
to
need
F.
to go from D to E, which is 20. And I have to go back to A, and E to A is 35.
Equals sports.
Equals what?
Sports. E to A.
EA Sports. In the game.
Just in the game. Them things are fast.
Who got me a total, friends?
All but
It's 300, 350.
It is not. Because I know what the answer is.
Then why'd you ask us for the answer?
Oh.
That's why it teaches these things.
I can't give you all the answers all the time. Huh? 201.
You just said
I literally just said that.
how many?
So you said about.
Okay, so the problem that you have with the table,
I get there, just like,
the hard part about the table is you can't see visually where you've gone and where you still need to go. Okay? I prefer the table because that's how my brain works. I like it in order. I like it. Okay. What I don't like about this graph is there's too many lines.
Uh-huh.
Too many lines, too many numbers to try to figure out what goes with what. But this is nice when you're going to see it visually. So here we know we started A. So we've got 75, 50, 28, 35, 15. My smaller goes to F.
50.
Oh, that's right there.
Okay. F can go 13, 65, 35, 30, or 40. So it's going to go 13.
Uh-oh.
G can go 32, 29, 28, or 50. So it's going to go here. But visually, I can see that I haven't gone to D yet, I haven't gone to E yet, and I haven't gone to B. So now I only have to look at 40, 48, or 30. B, I only have to look at 60 and 80. I know I have to go here, and I have to go here. It's gonna give you the same answer. Either way.
Right.
Okay,
I
so
got it.
whatever your heart desires,
Tables.
I don't care. So if they give you a graph and you prefer the table, make a table.
No, that's too much.
Nah,
If they give you a table and you prefer a graph, make a graph. If you want to just suck it up and use whatever they give you,
Yeah.
suck it up.
That's what I'm about.
Okay.
Or that.
So we found number 2. Does brute force seem practical here?
No.
Why?
It's too many.
There's too many. Okay, there's 7 vertices, which means my degree of each vertex is a 6, and 6 factorial means I have 720 circuits to draw.
What's up with you in 720?
I don't know, it just happened. Let it go.
Oh, that's 722.
So 720 is way too much for you to do.
Honestly, one is way too much.
I'm about to add his name up to that board too.
the
Oh,
whole
God.
class in there.
Don't want you're in the same boat.
You heard that too, stupid.
You drive the boat. Let me drive the boat.
Any questions?
You drive the boat.
Nah, this.
Can I go to the bathroom?
No. Can I go to the bathroom?
Eyes first.